Hello and welcome back to my gaming channel. So I received a comment in my last Plushables episode regarding when am I going to put my next timer. Well, I am working on that at the moment. However, one thing that I've been working on the last month is going to deeply satisfy you guys. Check this out. So on this Excel spreadsheet right here, I have made a bunch of sheets where I figure out 1 over a prime number. So on this Excel worksheet, I have been figuring out every prime number reciprocal, and these are a group of the results that I got here. You can see on the left side, those are the primes. That's the period. In many cases, it appears to be p minus 1. And in the case that it isn't, then basically those are numbers that indicate p minus 1 over z, the percentage, and the date that I calculated it. And I'm going to be doing it for some sort of a project. It's been just 1 month since I started working on this. Like, I take a prime number and I calculate 1 over that prime number, like for example 1 over 7, and so after the decimal point I do a thing like 1/7. So long divisions tend to work pretty easy in Excel if you do this. So what I'm going to do here is I'm going to take 7 away from 10, so this is for remainder, by the way, and 7 divided by 7 is 1, so this is just 1 with a remainder 3. And I multiply it by 10, I get 30. I take 28 away, which is 7 times 4. And then this next step, I take 20 minus 14, which is 2 times 7. And I take 60 minus 56, which is 8 times 7. And then 40 minus 35, which is 5 times 7. And 50 minus 49, which is 7 times 7. So 1/7 would be 0.142857, which has a cycle of 6 digits. Some prime reciprocals have p minus 1 digits in the cycle. So basically the remainder can be any number that is in the cycle, but in some scenarios that's not the case. For example, for 1/13th, because the cycle of 1/13th has 6 digits, because the fraction of 1/13 is 0.076923. So in that scenario, it's not possible to have every single remainder option. Unlike the 1/7 reciprocal, so the numbers that are part of the 1/7 reciprocal, I could just call it 142,857. So 142,857 times 2, times 3, times 4, times 5, and times 6 will have exactly the same combination of numbers. But 76,923 times 2 will have a different combination of numbers. And by the way, it is 0.076923. So if you multiply 76,923 by 3, by 4, by 9, 10, and 12, then you'll get the combination of numbers that are equal to 1/13th, considering after the decimal points. Because when the period is p minus 1 over z, then you would not have a group of alternatives consisting a selection of numbers. Therefore, it doesn't work with 1/13th, and it definitely doesn't work for 1/11th, but for 1/17th, 1/19th, 1/23rd, and 1/29th, the number of digits in the reciprocal cycle is p minus 1. So basically, after p minus 1 digits, then it goes back to the starting point. And yes, it works for 1/17th, because it goes 0.0588235294117647. I know it seems like a credit card number to you guys, but originally I would read the number out as 588 trillion 235 billion, 294 million, 117,647. And if I multiply that number by any number between 2 and 16, I'll get the same combination of numbers, of course, including that 0. And the really cool thing about it, so whatever 1 over p is the reciprocal of 1 over p, however many digits, like excluding the 0, you multiply it by p, then you will get p minus 1 amount of 9s. For example, if I would multiply 588 trillion, 235 billion, 294 million, 117,647 by 17, that's going to be 16 nines. Or for instance, 142,857 times 7 being 999,999, or if you want to say the easier way, 6 nines. Well, anyway, so the number I'm working on right now is 499. So I am now in the progress to find out what 1/499th is and how many digits are in that cycle of the 1/499th reciprocal. And in the scenario that the number of digits would be p minus 1, like you pick a prime and the number of digits in the cycle is p minus 1, then after the decimal point, you would expect the remainder to be anything, and the digit combination would be exactly the same. So right now I got up to this digit here. So again, I'm on 499. And in order to do this, I would take, so I got up to 191 as the remainder on column GE. And so I would take 499 times 3, which is 1,497. I would put a 3 up here, and I get remainder 413. Then I multiply it by 10, I get 4,130. And 499 times 8 is 3,992. So I take that, I put the 8 up here, and 1,380, and 499 times 2 is 998. So I put that up, I get remainder 382. How many digits does the cycle of 499 reciprocal have? Coming up to row HO over here, so I go up to 403, I multiply that by 10, and I take 3,992, and I get remainder 38. And because times 10 is less than 499, I say minus 0. Go up to 494. Here, that's 499 times 9. And look. There you go. I just come up to 498. Come up to column IR. So you know what that means. This is the area that I would put the number of digits in the period in the cycle of every prime reciprocal. So for 499, the number of digits in the cycle is 498. So there you go. It is one of those that it is p minus 1 digits in this cycle of 1 over p. So it's one of those factors, you know, like if you make a division by 7 and whatever remainder you get, then from the decimal point, then it will start with that number. It'll just keep going in that cycle. With 13, it works with just a group of numbers. Like if you get 1 over 13, and that only applies for half of the remainder options. But for 499, so for 1/499th, you would get exactly the same pattern of numbers that you would get if you were to get a different remainder. If you were to divide a number on your calculator, if you were to divide a number by 499. And again, I've been working on this for the last 1 month. I've been working on this since April 29th. On the day that I'm recording this, it is May 29th. And my target is to find the reciprocals of every prime number until 16,381. Why, you might ask? Because 16,384 is the maximum number of columns you have on an Excel spreadsheet. That's equal to XFD. And that's 16,381 is the highest prime number before that. Anyway, guys, so that's it for this video. Stay tuned. I'll see you some other time.